Okay, good evening, ladies and gentlemen. Okay, this is Professor David J. De Los Reyes. Past 1 hour ago, I assembled another 3.3 volt DC voltage regulator. The output current is 2.5 amperes. I place my name over here. Okay, the power input to the regulator is this one here. It's a 12 volt DC. So I don't have to, what you call this, insert or use a rectifier to put input on this voltage regulator, because the output of this one is actually 12 volt DC. So the only thing needed now is the 3.3 voltage regulator, the electrolytic capacitor on the secondary side to stabilize or to put more power on the secondary side. This is a 330 microfarad capacitor, 50 volts. And right now, I have checked the output voltage. This is the terminal of that's the terminal. It goes to the multimeter. It is set on voltage DC. And what comes out was a perfect one, 3.29, or approximately, this is 3.3 volts. So this was a perfect assembly thing, okay? Because I have used a breadboard and I got my solder station to solder the terminals very good. And what comes out is actually a 3.3 voltage regulator. The maximum current that it could give is 2.5 amperes. This is the date of the assembly, okay? 10/14/24. So right now, the output is 3.299 or 3.3. The last time around, the other 3.3 volt regulator that I have assembled is this one. That's the first one. And this is the second one. First one, second one. Okay, that's the first one, that's the second one. The output of this one is 3.3. The last time around, we have used this one to power up actually my transistor radio. The output is 3.3 approximately. But for this one here, this is more a complicated, what you call this, assembly, because I have used a transformer, okay? And the output of the transformer is still alternating current, so we must have to use a rectifier diode there. The first assembly, that's the rectifier diode. For the second one, I don't have any more rectifier diode because the output of the adapter is actually a 12 volt DC. So this is simpler, this is more complicated, but overall their output are actually the same, 3.3 and 3.3. Okay, this is more complicated, the first one, because I got a power transformer and a rectifier. Okay, and this one here doesn't have any rectifier now, because the output or the input going to the 3.3 volt regulator is actually a 12 volt DC. It's not regulated. It's a 12 volt DC, so we could input this one on the input of the regulator, 3.3 voltage regulator. The input, I think it goes to terminal number 3. The output is actually coming out from terminal number 2, and the first terminal is actually the ground. So what I have done here is actually to put a 330 microfarad capacitor to put more juice or more power on the secondary side. Okay, so what comes out is a 3.3 volts. I will be using this one to power up my assembled FM receiver. because the needed voltage for that one is 3 volts. We will be inputting 3.3. It's fine. It will not burn the circuit. 3.3, that's good enough. But it will go below 3. Okay, the reception will be bad because the receiver needs enough power for the components to be 100% efficient. So if 3.3, that's just good enough. So after this one, I will be inserting this 3.3 voltage regulator on the FM receiver that I have assembled. Okay, and it should work accordingly. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes. I have shown you another 3.3 voltage regulator that I have assembled to power up my AM FM assembled receiver. Good evening from Los Angeles.